We're going to start, right? Donc, bienvenue à cette troisième journée de l'édition 2021 des conférences Hugues-Leblanc au département de philosophie de l'UQAM. Mon nom est Christophe Malater et je suis professeur de philosophie des sciences ici à Montréal. Welcome to this third day of the 2021 Hugues-Leblanc lectures at the philosophy department of UQAM. I am Christophe Malater and I'm professor of philosophy of science here in Montreal. Je vais peut-être me répéter un petit peu pour celles et ceux qui étaient déjà là hier ou avant-hier, mais c'est toujours un honneur et un privilège que d'accueillir cette année Elliott. Elliott est professeur au département de philosophie de l'Université du Wisconsin à Madison. Il est titulaire des chaires William Willis et Hans Reichenbach. Et comme chacun le sait, vous devrez le savoir, c'est un éminent philosophe des sciences et un éminent philosophe de la biologie. It's a real honor and a privilege to have with us this year Elliott Sober. Elliott Sober is a William Willis Research Professor and a Hans Reichenbach Professor in the Department of Philosophy at the University of Wisconsin-Madison. And as everyone knows or should know, he is a wonderful philosopher of science and philosopher of biology. Donc, le reste de la conférence étant en anglais, je vais basculer vers l'anglais. I'm going to speak in English only from now on. For those of us who were not with us yesterday and the day before yesterday, the first lecture that we had was on parsimony and Occam's razor. The second one was on scientific realism. And today's third lecture and last lecture will be on values in science. So since the lectures are on Zoom, I'm going to repeat a few tips that should make everything run smoothly. So during the talk, please mute your microphone. During the Q&A session, if you wish to ask a question, you simply open the chat box, converser in French, and simply type H for hand in the chat. And then when it will be your turn to ask your question, please unmute and make sure your video is enabled. Please be respectful at all times and note also that the lectures are recorded. So now the lecture. Today's lecture is entitled Values in Science. It will run for about 15 minutes. And will then be followed by a commentary by Matt Barker, who is a professor of philosophy of science at Concordia University here in Montreal. We'll then have a brief reply by Elliott Sober, and we will open the floor for questions. With this, I think this is all I needed to say. So now join me in welcoming Elliott Sober for the third lecture of the 2021 Leblanc lectures. Elliott.
Yes. Thank you for coming back, if you were here before. I'm going to be talking about values in science, ethical values in particular, and more specifically still, the relationship of ethical and epistemic values in science. Here I'm having the same problem I had last time. As was true in the previous two lectures, I'll start with a little idea from probability theory that I'll be using subsequently. You've heard me speak on two occasions about the law of likelihood. The new concept today is the idea of expected value. Suppose you toss a fair coin 5 times, and there are two questions that may sound the same, but I'll talk about why they're actually different questions. How many heads would you expect to occur in 5 tosses? And what is the expected number of heads? The second of those questions, I'm using expectation in a technical mathematical sense. The mathematical expectation is the average number of heads that you'd get if you ran this experiment repeatedly. So the expected number of heads in this experiment is 2.5. Though, of course, when you toss the coin 5 times, you do not expect to get exactly 2.5 heads. How could that happen? So when I talk about expectations here, it's this average, what would occur if you repeat the experiment, and I'll be using that soon. Okay, so here are the topics I'll be talking about. First, I'll be drawing what I think is a very important distinction between actions and beliefs, the rational way of choosing an action and the rational evaluation of hypotheses, deciding what to believe. I'll be talking about Pascal's wager, about the debate between William James and W.K. Clifford. I'll be talking about a very influential article by Richard Rudner in the 1950s, the title of which was "The Scientist, Quasi-Scientist Makes Value Judgments." And then I'll finally talk about an idea from statistics that's called Stein's paradox. Some of these things I expect will be familiar to many of you. Possibly Stein's paradox is not, but that's good because I'll be explaining some basic things about it. Okay, let me start with something that I take to be obvious, and I bring it up because it'll allow me to isolate a less obvious point and question that I want to explore for the duration of the session today. So I think it's obvious that scientists, being people just like you and me, ought to take ethical considerations into account when they decide what they're going to do. I think it's absurd to suggest that scientists are somehow exempt from ethical considerations in deciding what actions they should be performed. And I just drew up quickly a list of some of the ways in which ethics enters into scientists deciding which actions to perform and which ones not to perform. There's the question of how you're going to spend your time. Are you going to investigate this problem or that one? Should you take money from corporations and foundations that want the research that you're going to do to come out a certain way? Should you publish your results? Should you plagiarize? Should you invent data? Should you conceal data? How should you treat your coworkers? How should you treat laboratory animals? Obviously, these are ethical considerations about action. And scientists, just like the rest of this, are obliged to take these into account in deciding which actions to perform. To me, obvious. Here's the harder question, which is what I'm really going to talk about. Besides choosing actions, what they're going to do, scientists also evaluate hypotheses. And the evaluation of hypotheses can take different forms. Some of these I've hinted at in the previous lectures. You might want to decide whether you should accept or reject a hypothesis, or make a decision about which hypotheses are more probable or which are favored by the evidence compared with other competing hypotheses, or which hypotheses are more predictably accurate. And in all these cases, in the evaluation of hypotheses, I'm interested in whether and why ethical considerations are relevant. So the starting point here is that ethics is obviously relevant in deciding how to act, but what about deciding what to believe? That's the focus for what follows. Is ethics relevant to that, or is it somehow irrelevant? I'll start with Pascal's wager, familiar to most of you, I suspect. It's about religious belief, but not science, but the kinds of points that I'll make about it are pertinent to any belief you might contemplate taking on. So here's a simple version of Pascal's wager. There are two possible, I'm going to treat beliefs as actions here in this setup of Pascal's wager. There are two things you could do. You could either believe that God exists or believe that God does not exist. There are two possible states of the world. Either God exists or God does not exist. And what you see in red are these probabilities. There's a probability P that God exists and 1 minus P that God does not exist. And then in green, you see the utilities, how good or bad it will be for you if you believe in God when God exists, then you get plus 1,000,000 points of utility and some unit of utility that we'll just take for granted. There's how good or bad it'll be for you if you do not believe in God and God exists. And then these other two numbers represent the utility of performing a given action, taking on this belief or that one, depending upon this being the state of the world. And I made up the numbers to represent the basic idea that if God exists, it makes a huge difference to you, says Pascal, whether you believe in God, by which he had in mind you're going to go to heaven, plus 1,000,000, let's call that, or alternatively, when God exists, if you don't believe in God, you'll go to hell, and that's very bad. So I have a very big number in the upper left-hand corner box. How can I get this arrow to go where I want? And a very large negative number down here. This is gigantically bigger than that. On the other hand, if God does not exist, it makes a very modest difference, says Pascal, as to whether you should believe or not believe. If you don't believe in God, and you will save yourself from certain activities, maybe going to church or synagogue or a mosque, that you would otherwise enjoy spending in other ways. So that's a slight benefit that you get. And if you believe in God and he doesn't exist, well, you're not going to go to heaven or hell, but you'll have to do some activities that you would otherwise maybe prefer not to do. So if God does not exist, you're better off not believing than believing. Let's suppose this is Pascal's idea, but the difference here is modest. Notice that this minus this is only 4 units, whereas this minus this is 2,000,000 units. So God exists makes a big difference to what, if that's true, then it makes a big difference. What your actions make a big difference in terms of your welfare. But if God does not exist, whether you believe or not, it makes a very modest difference. And what we can do now is use the idea of expected utility, which is the bread and butter tool of decision theory, to represent the expected utility of the two actions. So if you believe in God, there's a probability P that you'll get 1,000,000 units of utility. And there's a probability 1 minus P that you'll get minus 2 units. So the expected utility of belief is this plus this. And this is an average over the two possible states of the world, taking account their probabilities. Just like in the example of coin tossing, the expected number of heads in 5 tosses is the average number of heads that you'd get if you did the experiment again and again. And similarly here, you have the expected utility of not believing in God. With probability P, you get minus 1,000,000, and with probability 1 minus P, you get plus 2. So that's the expected utility of not believing. And then a little algebra shows you that believing in God is better than not believing in God in terms of the expected utilities of the two actions, precisely when P, the probability of God exists, is bigger than this very small number. I mean, it can't, if the probability of God's existing is 0, we don't have Pascal's wager. But if the probability of God's existing is tiny, but a little bit bigger than 0, then the rational thing for you to do in terms of maximizing your expected utility is to believe in God. So that, in a simplified form, is Pascal's argument. And the thing to notice here is that suppose you assign a very, very small probability to God's existence. It's maybe a little bit bigger than that, but not much bigger. So what this probability P that you've assigned here means is, given the evidence you have, you think it's enormously improbable that God exists. But the wager that Pascal puts before you says there's something else you should take into account besides the probability based on the evidence of God's existing. You should take into account the utilities of believing and disbelieving in these two possible states of the world. And given the numbers we have here, if the probability of God's existing is just a little bit, is just bigger than this tiny fraction over here, then the rational thing for you to do is to believe in God, even though the evidence tells you that it's almost certain that God does not exist. It's prudent for you to believe in God, though the evidence does not tell you to do that. So here we have a conflict, it seems, between going with the evidence and deciding, I'm not going to believe in God because the probability of God's existing is tiny. That'll be, let's call that evidentialism. Or the Pascalian idea that, sure, you want to take the probability into account here, but there's something else you've got to think about, namely the utilities of belief and disbelief. And with the numbers we have here, the utilities tell you, yeah, it's improbable that God exists, but you're better off believing. Familiar argument, I hope, to many of you. Here's a standard criticism of Pascal's wager. You can't believe something just by deciding to do so. It's not subject to the will to just throw a switch in your mind and say, okay, I believe in God now. Before you showed me the argument, I thought, no way does God exist. But now I'm sure, I believe now. We're not capable of doing that. And that fact about us, that believing something is not subject to the will in this way, is often taken to show that Pascal's wager is misguided, that you can't decide what to believe. And decision theory, properly used, is about actions subject to the will. They're not about believing or disbelieving things. I don't like this objection to Pascal's wager. There are lots of things you can't make happen just by deciding to do it. For example, you can't just decide today that you're going to get a university degree. I mean, you can't make that happen just by saying, yeah, I'll do it. But what you can do, and what many of you have done and will do, is you decide to take a series of actions that over several years will lead to your having that outcome. And I think that point applies to Pascal's wager. Pascal actually says in the Pensée, of course, you can't just decide to believe in God, but you can take steps to bring yourself into a state of belief. Go live with religious people, engage in rituals, and it'll start off feeling very alien and strange to you, but habits of faith will develop, and over a period of time, you will bring yourself into a state of belief. So to me, this is a good response that Pascal's make. It shows that this objection to his wager, I think, is faulty. Here's another standard criticism of Pascal's wager, which I think is pretty powerful. Pascal is assuming something very specific about what will happen to you if you believe in God and God exists. You'll go to heaven, he thinks. And what will happen to you if you don't believe in God and God exists, then you're going to go to hell. Well, that's a very specific theology. It's a very specific view of the pluses and minuses of belief and disbelief if God exists. That's one conception of God. There are others. And that's why this objection is called the many gods objection. Consider a different picture of God, that God puts you in heaven or hell, depending upon whether you've been a good person in your life, whether you've treated people with respect and altruistically. Then your theology, what you happen to believe about the existence of God, plays no role in whether you're going to go to heaven or hell. And for a third and rather perverse theology, think of this conception of God, that God sends everybody to heaven except the people who believe in him based on Pascal's wager. That's a conception of God which tells you that the prudential thing to do is to disbelieve. And Pascal has bought into a very specific form of Christianity, of course, in this argument. And the objection is, why should I think of God in the way that Pascal wants me to do? And I agree with that objection to the wager. There's some other things I don't like about the wager, but I won't go into that now. What I want to talk about is the debate between William James and W.K. Clifford, which to me is very Pascalian, and it avoids the objection to Pascal's wager that I called the many gods objection, the one I just stated. So William James wrote an essay called The Will to Believe, and W.K. Clifford wrote a response to it called The Ethics of Belief. James was a latter-day Pascalian. James says that if you're considering whether to believe a proposition and the evidence isn't completely decisive, and if believing you would help you a lot and not believing would hurt you, then believing the hypothesis is permissible. And W.K. Clifford said in a famous statement that I quote here, he said, "It's wrong always, everywhere, and for anyone to believe anything upon insufficient evidence." So Clifford is a solid evidentialist about belief. You should believe according to the evidence and only according to the evidence. And James is a Pascalian because he thinks that utilities are properly taken into account when you decide what to believe. So far, James just sounds like Pascal, but what he has in mind is an idea that I think has nothing particularly to do with heaven and hell or conceiving of God in one way or another. So I think James's version of this argument is an improvement compared to Pascal's formulation. And so I said that Clifford is an evidentialist, and James, of course, is a pragmatist. Part of what's relevant in deciding what to believe is what's useful to believe. Okay, so here's an example of the kind of argument James has, and I'm going to put it in the third person talking about this guy named Joe. So here's the argument. Joe is very depressed and drugs and therapy have not helped him. Second premise, if Joe believes in God, his depression will lift and he will be able to have a fruitful and meaningful life. Third premise, if Joe does not believe in God, his depression will remain and will probably get worse. And from these three premises, the conclusion is drawn that Joe should do what he can to believe in God. I think this is a good argument. If the premises are true, that's what Joe should do. Now, in saying that, of course, I am certainly not claiming that everybody is like Joe. Not all of us are depressed. Not all of us are such that believing in God or disbelieving in God will change our state of depression if we are depressed. This is a highly specific picture that's true of maybe a very small number of people, but that's the case I want to look at here. And I think this Pascalian argument is convincing. I think Joe should do what he can to believe in God, given the facts as I'm assuming them to be in the premises here. And notice, there's no issue about whether God would send Joe to heaven or hell or anything. It's nothing theological. This is a purely psychological argument, and I think a compelling one. Here's what W.K. Clifford said in response to James. He said, "If I let myself believe anything on insufficient evidence, there may be no great harm done by the mere belief. It may be true after all, or I may never have occasion to exhibit it in outward acts. But I cannot help doing this great wrong towards man, that I make myself credulous. The danger to society is not merely that it should believe wrong things, though that is great enough, but that it should become credulous and lose the habit of testing things and inquiring into them, for then it must sink back into savagery." I think this is a very poor argument of W.K. Clifford's. Look, people have been believing various things without sufficient evidence for ages. And look around, we apparently have not, as Clifford would have it, sunk back into savagery. So I think the danger that Clifford describes is vastly overstated. It's in fact extremely small. If Joe decides to believe in God, society's not going to collapse. I mean, it's ridiculous. This is like almost like scare tactics, something terrible will happen to you or to the world in general if you do this, so don't do it. I mean, come on, this is ridiculous. So I'm on James's side here. I think there are situations in which a person should believe a proposition because the act of believing would have good ethical consequences, and saving yourself from a life of despair is a good thing to do. It's prudent. Also, ethics is on the side of doing what you can to lift yourself out of depression. And of course, James and Clifford were primarily thinking about religious belief here, but I mean, change the argument a little bit and we can talk about any belief at all and talk about what you should do if belief and disbelief have certain prudential consequences. So we're not doing theology anymore. Anyhow, here's a little aside about the invitation that James and Pascal are giving us. They're inviting us to believe things that the evidence does not support. Maybe, this is a speculation, scientists and other intellectuals like philosophers have a special duty to decline the invitation that James issues. That is, it's part of our job description that we shouldn't do what James and Pascal are saying we ought to do. We should be evidentialists. If that's right, then science, and maybe we should do that because it helps us, or maybe even essential for us to do our job properly, that we maintain a strict evidentialism. If that's right, then scientists and philosophers are in this respect obliged to be altruistic. They're sacrificing an opportunity they have to advance their own welfare so that others will benefit from their doing a good job as scientists or as philosophers. This is an idea that a former student at UW published some years back in the Journal of Philosophy. I think it's an interesting connection of the issue of evidentialism and prudentialism to the question of altruism. And maybe some of us has special duties to be altruistic. Okay, now I'll fast forward to the 1950s when Richard Rudner published this article. It's in the tradition of Pascal and James. There's some twists in it that I'll explain. And you can get a feeling for where he's going by looking at the title of his paper. The paper is called "The Scientist Qua Scientist Makes Value Judgments." So here's Rudner's argument. It's an argument that Heather Douglas in her 2009 book develops and examines and puts in some historical context. Rudner says, scientists, first of all, ought to evaluate whether a theory should be accepted or rejected. That's part of their job description. To do so, they need to decide whether the evidence is strong enough to accept, strong enough to reject. And here's the special thing that's important here. For Rudner, whether the evidence is strong enough depends on the ethical consequences of mistaken acceptance and the consequences of mistaken rejection. And from these three premises, Rudner concludes, scientists ought to use ethical criteria in evaluating theories. So let's represent the problem that Rudner is discussing here in the same way I earlier represented Pascal's wager. So you have some hypothesis H. The scientists will either accept it or reject it, believe H or believe not H. And there are two possible states of the world, H and not H. And each of those has a certain probability. And I'm going to assume, just to keep this simple, I don't think this distorts the argument, that you're better off believing true things than false things. So if P is true, you're better off believing it than not believing it. And if H is false, you're better off not believing H than believing it. So that's what those inequality signs mean. Then we can, just like I did before with Pascal's wager, represent the expected utility of believing H, the expected utility of believing not H, and get a criterion for whether you should believe H or not. And this is just what I did before with Pascal's wager. That was the expected utility of believing in God. This was the expected utility of not believing in God. And down here, all I did was rearrange some of the P's and U's and whatever, so that on the left-hand side of this inequality, I have a ratio of probabilities And on the right-hand side, I have a ratio of the importance of different propositions, of different states of different propositions. Let me now talk about what importance means here. So what's the importance of the hypothesis H? The importance of it is the difference between what happens to you if you believe it minus what happens to you if you disbelieve it. In Pascal's wager, where H is the proposition God exists, the importance is huge. Because if you believe that God exists and God exists, you get plus a million. And if you don't believe in God, if you disbelieve in God and God exists, you get minus a million. And subtract U3 from U1 and you get 2 million. That's a giant number. So God is existing is hugely important. Whereas in the wager of Pascal, God's not existing is not important at all, because how well off you are here is only modestly different, modestly greater than how well off you are if you believe in God when God doesn't exist. So God's not existing doesn't matter that much, but God's existing, if it's true, really matters a lot in terms of what you ought to do. Well, here's an example in which this is not Pascal's wager. We have a kind of symmetry here. Proposition H has an importance of 7, and the proposition of not H has an importance of 7 also. So so that's a 7, and that's a 7. So the criterion for what you should believe is you should believe H if this ratio is greater than 1, 7 divided by 7. And that's true exactly when P is greater than a half. So if the proposition H and not, the propositions H and not H are equally important, you should just believe the one that has the higher probability. But suppose, and this is more like Pascal's wager, suppose that H has a higher importance, 80, compared with not H, which has an importance of only 1. What should you do? Then you should believe H as long as P is bigger than some very small value, as was true in Pascal's wager. So you lower your minimum probability if H is much more important than not H. Okay, so what does this show? And this is just learning from Pascal's wager. If we treat belief as a decision problem, then the good and bad consequences of belief and disbelief matter because they affect the ratio of importances. The key thing here is that besides probabilities mattering in deciding whether you should believe H or believe not H, the ratio of the importances of the two propositions, these guys over here, they matter too. We've separated these two things from each other. If the two hypotheses are equally important, just believe the one that has the higher probability. If H is more important, like in Pascal's wager, you should lower your threshold for accepting H. You should believe in God as long as the probability of God's existing is greater than 1 in a million. Not 1/2, that's not your standard anymore. Your cutoff is much smaller than 1/2 if H is a way more important proposition. Now, this is a kind of correction to what Rudner says, or maybe just a refinement. Rudner says that what really matters here is how bad mistaken belief and mistaken acceptance are. These are the two utilities that he thinks matters. How bad would it be for you if you believed H when it's false? Whoops, that's over here. Get my arrow in the right place. How bad would it be for you if you believed H when H is false? And how bad would it be if you believe not H when H is true? And, that's certainly relevant, but I hope the little exercise modeled on Pascal's wager says, well, yeah, the values of U2 and U3 matter, but what really matters is the ratio of importances. This is the thing that's the key thing here. Here are two critics of Richard Rudner, Dick Jeffrey and Isaac Levi, they looked at Rudner's argument and had two very different objections to it. Jeffrey rejected the first premise. He doesn't think that scientists ought to evaluate whether a theory should be accepted or rejected. And Levi rejects three. He thinks, yeah, you should be accepting and rejecting if you're a scientist, but you shouldn't let ethics influence how you do that. Here's what Jeffrey says. He's a Bayesian. He thinks, and this connects to something I briefly mentioned yesterday, he thinks that the idea of a dichotomous belief that you accept or reject something is wrong-headed. He thinks that scientists and the rest of us should have degrees of belief, degrees of confidence. We shouldn't use the dichotomous concept belief, don't believe. And so the idea of acceptance and rejection, throw that away. Don't do that. And of course, if that's true, then Rudner's argument fails because scientists shouldn't do what the first premise of Rudner's argument says they should do, which is they are in the business of accepting and rejecting. Jeffrey says, no, they're not. They shouldn't do that. Rudner replied by saying that even if you're a Bayesian, you still need to decide whether or not to accept a given probability statement, like the probability of H is 0.7 or something. And so Rudner thinks that his argument applies even to Bayesians who want to have degrees of belief. To have degrees of belief, you assign probabilities, which Rudner thinks means you believe the proposition that says that H has a probability of whatever value you want to have there. Jeffrey's reply is something that he calls radical probabilism. He says there's no need for the dichotomous choice between acceptance and rejection for any proposition. His idea is that we should assign probabilities to non-probabilistic propositions, and that we should assign probabilities to statements about probabilities, that we should assign probabilities to statements about probabilities about probabilities. It's turtles all the way down as far as Dick Jeffrey has in mind. So we never have to accept or reject anything. Here's Levi's reply to Rudner. He thinks that scientists do accept and reject, and that that's something they ought to do. But Levi thinks that acceptance and rejection should not be influenced by ethical considerations or personal preferences. What he thinks is that there are epistemic values that determine what the minimum probability is for accepting a hypothesis, where the minimum probability that's needed to accept H1 might differ from the minimum probability that's needed to accept H2. How do you get these? How do you figure out what the minimum probabilities should be? Well, kind of like Kuhn, although I don't know that Isaac Levi would like me to connect him to Kuhn here. Levi thinks that there are virtues that hypotheses have, like how explanatory they are, their values that they have, how simple they are, how unified they are, how well they fit the data, and that all of these considerations, which allow you to talk about how good a hypothesis H1 is or how good a hypothesis H2 are, allow you to decide how probable H1 needs to be if you're going to accept it. So if H1 is super explanatory and really simple, Levi will say, hey, you get to believe that even if the probability of its being true is less than half. On the other hand, if H1 is super complicated and not very explanatory, then you got to have a much higher probability for the hypothesis if you're going to go ahead and believe it. So he thinks that, yeah, scientists and the rest of us should accept and reject, but we should do so based on purely epistemic values, not prudential personal values, not ethical, not political values. So those are the two critics. And you can see the connection to the first objection to Pascal. You could put Jeffrey and Rudner as you can think of Jeffrey and Levi as saying, look, decision theory is about actions. Don't do that when it comes to deciding what to believe. Okay, here's a little detour, a little footnote. Suppose Rudner's wrong. Suppose that rational belief without ethical consideration is possible. That leaves open whether it's desirable to form beliefs without taking account of the ethical consequences of erroneous belief. We could do it. Should we do it? It's the question I want to look at briefly here. And here's a suggestion to consider, which pertains perhaps not to all of us, but to scientists. And here I'm taking Rudner's idea. He thinks that the scientists have certain duties, and he tries to tell them how to go about it. Should scientists let their ethical and political values influence what they believe? And here's the suggestion that scientists need to consider the effect on society of their actions, including the assertions they make in public, but they should decide what is true or probably true without bringing ethical considerations to bear. That is, they should do their epistemology in a value-free way, free of ethical considerations. And then after scientists tell the rest of us what their non-ethical considerations are about the probability of global warming or whatever the topic is, it's up to society at large to decide what policies are best. And part of the motivation for this suggestion is that scientists often have no special expertise on the ethical issues that policy making raises. So what I'm suggesting here is maybe it would be a good thing if scientists did their epistemology without paying attention to ethics. Of course, when they say stuff in public, they've got to worry about ethical considerations. But just in terms of how they should go about formulating their beliefs about what's going on in the world, they should leave the ethics at the door of their laboratories. And then they can tell policymakers and society at large, here's the way I think the world is, and I've reached my conclusions without letting any ethical considerations affect what I decide. And then policymakers and the public at large get to decide what's the best policy on the basis of that. So with that suggestion before us, let's consider this argument, which I'm putting up here not to endorse, but to get you to consider. Premise of the argument says, look, governments will enact better policies and laws if the scientific advice they receive is neutral with respect to the different ethical and political views that people may have. And scientists should therefore form their beliefs or better their degrees of certainty without regard to the ethical consequences of error. And then they should truthfully report these findings to the government. Maybe this is a recipe for a well-functioning society where there's a division of labor. The scientists take care of figuring out the way the world is, and then a society, perhaps the policymakers in a government, take that information, which is ethically neutral, and then, of course, bring ethics to bear in deciding what policy measures should be taken, say, to combat global warming. And the point I would make about this argument is that it's certain, I think it's obvious when you think about it, that it's got to be qualified. Because it makes assumptions about how governments behave. Maybe this is a reasonably good argument for well-functioning democracies, but maybe in dictatorships, this is a bad idea, because what scientists should be doing is trying to get dictatorships to do things that are less awful rather than more awful, and therefore they're not obliged to carry out their belief formation or what they tell the government in this ethically neutral way. So, and it could be that even in democracies, the situation is more nuanced than this argument presents it. But I think it's worth considering as a kind of detour away from Rudner's own argument, that even if it were possible to do science in a value-free way, why would it be a good idea, or in what circumstances would it be a good idea for scientists to actually do that or try to do that? Okay, so let me now try to summarize where we are now before I move on to the final topic. First of all, obvious point that I began with, the actions that scientists take are just as much subject to ethical scrutiny as the actions performed by non-scientists. So the idea that the activity of science is value-free strikes me as just obviously wrong. What's more nuanced as a question is whether beliefs should be influenced, scientists' beliefs should be influenced by ethical and political values. And Rudner says yes, his critics say no. And then there's this third point about what would be the best configuration of a society in terms of the division of labor between scientific inquiry and governmental policymaking. And so far, you know, it might look like, well, I don't know what it looks like yet, but here's a new argument, my last one, for the hypothesis that evaluation, ethical evaluation, cannot be independent, epistemic evaluation, if they're deciding whether to believe or disbelieve a hypothesis and things like that, cannot be independent of ethical value judgment. So I'm going to make an argument now that's very much in the spirit of Rudner. But it's really very different from Rudner's thing. And it concerns something that seems on the face of it doesn't have anything to do with ethics, and it's about estimation. And it's due to a statistician named Charles Stein. And he came up with something and inspired a field of statistics that is full of surprising, paradoxical things. It's philosophically very rich and interesting. I'll just tell you a little bit about it. So here's an example of the kind of estimation problem that Stein was talking about. You want to estimate three quantities, and they have nothing to do with each other. Okay, the first one is the frequency of high blood pressure in residents of Beijing in 2019. The second quantity is the frequency of Apple laptops in Madison in 2018. And the third is the frequency of rainy hours in Montreal in 2017. And suppose you have three different data sets, one for each of these estimation problems, which tells you in your sample, what's the frequency of high blood pressure in the people in this sample? What's the frequency of Apple laptops in 1,000 people in Madison? What's the frequency of rainy hours in, the 50 days of the year that you looked at in Montreal? And it seems obvious that D2 and D3 are entirely irrelevant to estimating Q1. Q1 is not about Apple laptops in Madison. It's not about rainy hours in Montreal. It's about high blood pressure in Beijing. And the only data set that's relevant here is D1. First point seems obvious. And the second point is that a natural estimate is to use the sample frequencies you have as your best estimate. So if 32% of the people you sampled in Beijing had high blood pressure, a good estimate of the frequency of high blood pressure, it's a random sample, suppose, a good estimate of the frequency of high blood pressure in all of Beijing is, 32%. And in doing that, you're using the idea of maximum likelihood estimation. And you'll remember likelihoods from yesterday and the day before. You're choosing an estimate that has this property. X is the maximum likelihood estimate of a quantity theta. All that means is the probability of the data, if theta equals X, is greater than the probability of the data if you assign some other value, some value other than X, namely Y, to theta. So if 32% of the people in your sample in Beijing had high blood pressure, and you assume that the frequency of high blood pressure in the whole city of Beijing is 32%, that makes your observations more probable than if you assign the city a frequency of high blood pressure, say 98%. Then it'll be rather surprising that only 32% of the people in your sample had high blood pressure. So I hope you find maximum likelihood estimation intuitive. And we've already seen a glimpse of this idea about estimation yesterday and the day before when I talked about the law of likelihood. And you can think of H1 and H2, if you like, as different hypotheses about the frequency of high blood pressure in Beijing. And O is the observation that 32% of the people in your sample had high blood pressure. Well, the probability of getting that sample if H1 is true is greater than the probability of getting that observation if H2 is true. So maximum likelihood estimation just seems to make sense in the same way that the law of likelihood makes sense. Seems pretty intuitive. But now I have some bad news for maximum likelihood estimation. That's the new thing that comes out of Stein and his influence on statistics. So here's some terminology. An estimate is a proposition about the value of a quantity. So my estimate of the frequency of high blood pressure in Beijing in that year is 32%. It's a statement. An estimator is a rule for deriving an estimate for the value of a quantity from observations. So we can talk both about the maximum likelihood estimate of a quantity, and also about the rule of maximum likelihood estimation. And now I have to introduce the concept of the risk of an estimator. New concept. So if the mean height in the population we're talking about is 5 feet 8 inches tall, and you repeatedly sample 100 individuals, the sample means in your different 100 observation samples will sometimes be greater than 5 feet 8 inches, and sometimes they'll be below. So can you visualize this? I got this population, say the people in Madison. Suppose the true average height is 5 feet 8 inches. And I'm going to look at 100 people and look at what their average height is. And then look at another 100 people and another 100 people. Some of those estimates will turn out to be, the frequency in the sample will sometimes be below the population average. Sometimes it'll be above the population average. And now I can define what the risk is. The risk is just the average square distance between the population mean and the different sample means. So one day I took a sample and I got 5 feet 2 inches. A day later, I did a sample and I got 6 feet. A third day, I took a sample of 100 and I got 5 feet 7 inches. And you have these different samples, and you can talk about the risk of the of an estimator as the average square difference, if you like, the average difference between the true value and the different values you're getting here. And it's an expectation in the sense of expected number, in the sense I talked about. You're asking yourself, what would happen if I did this estimation problem again and again? How much deviation from the true value would I get on average? Here's an even simpler example. So think of a kitchen scale, and you can weigh an apple on the scale. But the scale is not perfect, so if you weigh it one day after another, sometimes it'll give you a number that's a little bit less than the true value. Sometimes it'll give you a number that's a little bit greater. And if you do this a lot, you can say, well, here's on average how much deviation from the true value this scale is doing. And that's the risk of using the scale. It's the risk of being off from the true value. And the greater the deviation that you expect, the bigger the risk. That's the concept we have here. So we now know what the risk of an estimator is. And we can think about other estimators in the same way. So here's an interesting fact. So what should you use when you're estimating the frequency of high blood pressure in Beijing in that year? You could take the average in your sample, that's the maximum likelihood estimator. You could take the median value, that just means the middle value, or you could take 1/2 of the average. And what you have here is different values. The theta is the different values that the frequency of high blood pressure in Beijing might take. It could be 0, it could be 100, it could be anything in between there. And what you see here is that using the average, which is what the maximum likelihood estimator does, involves less risk than using the median, because no matter what theta is, the risk that you run by using the average as your estimator is always lower than the risk you run if you use the median as your estimator. So that makes the average look like a much more sensible estimation procedure than the median, because no matter what theta is, you expect to have less of a deviation from the true value if you use the average as your estimator rather than the median. 1/2 the average turns out to be better, have a lower risk than the average when theta is very small. Trust me. Here's some vocabulary. I'm going to have to stop for a minute. I'm sorry. I just opened the cut on my finger. I'll be right back. 1 second. Okay, can you hear me? Good. Okay, so here's another piece of terminology. And I'll just use it first before I explain it. Given this picture here, you can say that average strongly dominates median. The estimation procedure of going with the average as your estimate, the sample average, strongly dominates the estimation procedure of using the median value in your sample as your estimator. Because no matter what the value of theta is, average has a lower risk than median. So, and I think you'll agree with me that if you had to choose between a kitchen scale, sorry, let me not change the example. You had to choose between, when you're dealing with estimating the frequency of high blood pressure in Beijing, you should use the average as opposed to the median, because your risk is lower no matter what theta is, of course. Whereas as between the average and 1/2 the average, neither dominates the other. It depends on theta, which is going to do a better job for you. And if you don't know theta, you don't know which is better. Okay, here's the final definition. An estimator is inadmissible precisely when it's dominated by some other estimator. And an admissible estimator is not dominated by any other estimator. So back here, median is inadmissible because it's dominated by average. But from what you see here, you can't figure out whether average is admissible, which is what the maximum likelihood estimator is, taking the average in your sample, or whether 1/2 is admissible, or whether neither of them is. Because to say that an estimator is admissible, you're saying it's not dominated by any other estimators. And you don't have any information about what other possible estimators are like in this picture. So there's no way of saying whether average or 1/2 the average is admissible. Okay, so let's use that and go back to maximum likelihood estimation. And here's some good news for maximum likelihood estimation. For data drawn from a normal distribution, maximum likelihood estimation is admissible That is, if you're interested in estimating just the average, the frequency of high blood pressure in Beijing, use maximum likelihood estimation. And if your sample is 31% of the people in your sample have high blood pressure, your best estimate, according to maximum likelihood estimation, is that 32% of the whole city has that. And the estimation procedure you just followed isn't dominated by any other estimate. This is great. This makes maximum likelihood estimation not just sound good, but it actually has a provably desirable property. No other estimator is going to dominate it. Now here's the bad news, and this is a big surprise. It was a big surprise in statistics when it came out. Stein proved that when you're estimating 3 or more quantities, and you want to minimize your total risk, maximum likelihood estimation is not admissible. So back to the threefold problem I described: blood pressure in Beijing, the frequency of Apple laptops in Madison, and the frequency of rainy days in Montreal. If you want to estimate those 3 quantities together, and what you want to do is minimize your total risk over these 3 problems, you can't use maximum likelihood estimation. And then James and Stein proved another result. Effort and Morris proved another result. They found estimators that do better than maximum likelihood estimates do. And they're called shrinkage estimators, where you adjust the maximum likelihood estimation by shrinking it towards 0 or shrinking it some other direction. So this sounds crazy, doesn't it? Because it sounds like you should bring these 3. You start with maximum likelihood estimation for the Beijing, the Madison, and the Montreal questions. You don't treat them as separate, but you shrink them all towards some value or other. And the shrinkage estimator you're using dominates maximum likelihood estimation. It's provably better in terms of the risk that you're undertaking by shrinking as compared to the risk you're taking if you use straight up maximum likelihood estimation. Some more results. Those 2 shrinkage estimators are themselves inadmissible. Sounds like a nightmare. But here's some positive result, which is there are other shrinkage estimators, not the ones I mentioned before, that dominate maximum likelihood estimation and are admissible. So there are shrinkage estimators, weird estimators, that do better than maximum likelihood, and no estimator dominates them. These guys are admissible when you're estimating 5 or more quantities. This is crazy, isn't it? Okay, so where are we? Well, if you want to just estimate 1 quantity, maximum likelihood is admissible. And that's kind of makes sense. That accords with our intuitions. That's a good idea. If you want to estimate 3 or more quantities and you care about your total risk, you want to minimize the sum of the risks across the 3 or more decision problems or estimation problems you're doing. Maximum likelihood estimation is inadmissible. But if you want to estimate 3 or more quantities, and what you want to do is minimize the risk in each of them, MLE is great then. Strange world. Well, minimizing risk seems like an epistemic goal. I mean, just like in our kitchen scale, you'd like to use a scale that deviates from the true value less on average than a scale that deviates more. But whether you should be a lumper or a splitter about risk seems to be a practical question. And it can have an ethical dimension here. So should you, when you ask the question, should I minimize the total risk across 3 or more estimation problems, or should I try to minimize the risk on each? I think this has a practical dimension to it, and it can have an ethical dimension too. So let me talk about that. Why can't I get this to go? So we have 2 labs. One is called lumper and the other is called splitter. And each of them want to estimate the same 5 quantities, but the labs have different purposes. In the lumper lab, they're trying to build a single vaccine, and estimates of these 5 quantities are needed to achieve that single goal. Whereas in the splitter lab, they're trying to build 5 different vaccines, and estimates of the 5 quantities are needed because each is relevant to just one of the 5 goals. So you can I think you can imagine in a situation like this that the lumper lab says, I just want to minimize my total risk across these 5 problems. Whereas down here, you can imagine them deciding that what we're going to do is try to minimize the risk on each of them separately and not lump them together because they're part of different projects. So I think it opens the door to a kind of what did I do? Sorry. So these 2 labs, I'm thinking, will possibly go about their estimation procedure in different ways because they have different goals. And relative to those different goals, there are different best decisions for how to minimize risk. That's what I think that shows. So let's return to the broad distinction between evidential and pragmatism. It certainly was, I introduced that when I talked about William James and W.K. Clifford. It already was out there on the table in connection with Pascal's wager. Evidentialism says that your beliefs, degrees of belief, should be influenced solely by the evidence. Pragmatism says that what you believe should be influenced by utilities, not just probabilities. And I think Stein's paradox provides a setting in which pragmatism makes some sense. Perhaps more sense than it made in Pascal's wager, or that it made, well, I don't know about, I agreed with James's pragmatism there. So I think of it as, let me rephrase, I think that Stein's paradox supplements, doesn't replace, but supplements the pragmatism we already have in Pascal and James. And that's, to me, philosophically interesting. So thanks.
Well, thank you so much, Elliott. This is when we all clap virtually. And so now we'll have a commentary by Matt Barker from Concordia University. Do you have slides, Matt, that you want to show?
Yeah, I do.
I'll take mine down.
Sure. Christoph, could you remind me what time we're to end?
We were, I know, five-ish. Yesterday and the day before, we ended at 5:15. And this is fine with everyone, then this is what we'll do. Especially if this is fine with you, Elliott.
Sure.
So, because if you have like 12 minutes, 10, 12 minutes, that would be good.
Sure.
And then we'll have the questions, right?
Great. Okay, so let me see. Okay, so people can see the slides? Yeah?
Yes.
White screen? Okay. So I wanted to start, thanks for the talk, Elliott. I wanted to start just by saying a few things that I've always liked about Elliott's talks, including this one, and his work in general. There's lots of things, but there are three I wanted to point to. One is how exacting the work is, and I think it's something we've all seen on display in all three talks this week. Another is how restrained or modest it is. I don't know which of these is the better descriptor, restrained or modest. Maybe modest is better. Restrained suggests, that you really want something and you're holding back from it. I don't think Elliott's doing that with his conclusions, but so maybe modest is the better one, where he's very exacting and often aims for what seem like modest conclusions. It makes it hard to find something to really dig into and criticize, but they end up being progressive as well. So those are many virtues all in one. And just as an example of this, before I get to some of the questions I want to raise, I think Elliott pointed at this a bit himself in his talk. So it's what I think is a really important correction to Rudner's 1953 article. So this is a passage from Rudner's article where he says, in accepting a hypothesis, the scientist must make, it's hard for me to read it because must make the decision that the evidence is sufficiently strong or that the probability is sufficiently high to warrant the acceptance of the hypothesis. Obviously, our decision regarding the evidence and respecting how strong is strong enough is going to be a function of the importance in the typically ethical sense. And I think what Elliott pointed out was an important point that Rudner overlooked, which is that it's not just a function of the importance, it's a function of the importance ratio that Elliott carefully defined. And that will end up mattering a lot to people who end up wanting to build models around this stuff. You get different algorithms, different models. So that's an example of something that looks small and modest, but I think it's real and important progress. So now to the stuff I want to talk about. I first want to clarify some terminology, and here I'd like to put some of Elliott's discussion into contact with recent work on, well, it often goes by the name science and values, the so-called science and values literature, which is popular right now. It often is written in a way that's a bit disconnected from some of the older stuff like Rudner and Levi that Elliott discussed. And I think that's a shame because there's a real continuation right through the history there. But let me try and clear away a lot of what's discussed in this area and focus on one thing. So to do that, I'll first distinguish, as Elliott did himself, between belief and action. There are some, I think, missteps in this area that can be avoided by a few other distinctions. So when you're talking about belief, there's this distinction Elliott made between degrees of belief versus accepting as true. I think that's an important distinction with respect to whether one believes a hypothesis. And then action as well. Some people will point out, well, believing, on some views anyway, is itself an action. And so we want to be careful to distinguish between acting as if something is true and other kinds of policy-related actions you might take up in light of a hypothesis, regardless of your belief about it. Okay, so another distinction, this has become more important recently, this particular way of thinking about pragmatism and evidentialism, is the distinction between epistemic value and non-epistemic value. And I assume for now that the two terms are clear enough. In a moment, you'll see how it goes to work in a question I'll pose. And then a three-way distinction is between what is the case, what must be the case, and what should be the case. And so often I think the question on most people's minds in this literature now is best put by saying it's about non-epistemic value and whether those kinds of values should influence belief. And I tend to agree with Elliott. I think the concept of degrees of belief is important. And I resist the idea that we have to always make a decisive choice about whether we accept a hypothesis or not. So if we focus on those things, I think the central problem is, should non-epistemic values help shape degrees of beliefs regarding hypotheses in science? And so I'm just going to try to articulate three questions and talk a bit about each. The first is, what is Elliott's answer to this problem that I've specified? Another is, what answer, if any, does the Joe argument, which I think is perhaps Elliott's version of something he reads in James, but you can clarify that afterwards, Elliott, if you want to, but it's the Joe argument that I think is interesting. And what answer, if any, does the Joe argument suggest for the central problem? And then, can Rudner's argument be prevented from establishing a yes answer, a kind of pragmatism about that central problem? So the first question, what's Elliott's answer to the central problem? It doesn't jump right out to me. And you might have been struck by two things that look a bit in tension in the talk. And ultimately, I don't think they're really in tension, but one of them, it says, this is what Elliott said, I think there are situations in which a person should believe a proposition because the act of believing would have good ethical consequences. So that sounds pretty pragmatist. That was earlier in the talk when talking about James and Pascal's wager. And then later he mentions a suggestion that scientists should decide what is true or probably true without bringing ethical considerations to bear. After scientists tell us their non-ethical conclusions, it's up to society, and then he goes on and fills out a proposal. So it might look like in the first one, there's a kind of pragmatism that seems in tension with this next suggestion, which doesn't look very pragmatist. So one point I want to make about these is I think you can construe them both as being about belief as acceptance. And that would allow you to say, well, the ethical considerations at play here are nothing shows or is saying that they should be influencing degrees of belief. It's about acceptance, whether you decide something is true or to act as though it's true. So that's one kind of pragmatism resisted. The other point to make here is, of course, the second claim is about scientists in particular. And the first claim is about particular situations, and it might be that those situations don't overlap in any way with the kinds of cases Elliott's talking about in the second quote. And so that's a way to resist any contradiction you might think is there. So a second question, what answer, if any, does Elliott's Joe argument suggest for the central problem? So this is the way that Elliott put it. Joe is very depressed and drugs and therapy have not helped. If Joe believes in God, his depression will lift and he will be able to have a fruitful and meaningful life. If Joe does not believe in God, his depression will remain and will probably get worse. So Joe should do what he can to believe in God. So just a question of clarification that I think it's worth asking. Is James' style pragmatism supposed to best explain why this argument is compelling? So Elliott mentioned that he finds this to be a compelling argument. And we know Elliott has some views on how you should interpret arguments to the best explanation. So is that what's going on here? Is there some kind of best explanation argument? Or instead is the argument compelling on its own and that supports James style pragmatism in some other way without appeal to best explanation? But the point about the argument to make, let's see if I can see my own text here. 4 is compatible with saying no to the central problem, right? So if you remember, the central problem is about whether non-epistemic values should help shape degrees of beliefs about hypotheses in science. Well, you could say no to that and yet still find this argument compelling. Joe should, Joe's being told he should do what he can to believe in God. Well, that could include going about and collecting more evidence to see if he can gather evidence that points in favor of believing God. So it leaves open that the route Joe takes to going about doing what he can to believe in God is strictly through evidence. Okay, and so the other question to ask: can Rudner's argument be prevented from establishing a yes answer to the central problem, or establishing a kind of pragmatism? So this is just Rudner's argument again. Scientists ought to evaluate whether a theory should be accepted or rejected. To do that, they need to decide whether the evidence is strong enough to accept or strong enough to reject. And then whether the evidence is strong enough depends on the ethical consequences of mistaken acceptance and mistaken rejection. So scientists ought to use ethical criteria in evaluating theories. So one point to make here is notice that Rudner, if we ask how he's addressing the central problem that I've posed, he's addressing it indirectly. The central problem is a normative one. It's should non-epistemic values help shape degrees of belief about hypotheses in science. And Rudner's argument gets to that by first making a modal claim that it can't be otherwise. You can't make a decision about whether the evidence is strong enough without appealing to ethical consequences. It's something that must be done by the very nature of acceptance and rejection in science. And for that reason, it's something we should do, perhaps. So I just wanted to point out that 1 to 3, I think, are consistent with thinking that only evidence determines degrees of belief, and that ethics must then help decide whether to accept, right? So if you think of acceptance as this thing that comes further downstream, before that, you've got to figure out what your degrees of belief are. And it looks like you can accept the 3 premises and say, well, what they're really telling us about is acceptance. Further upstream, degrees of belief are so far not addressed by ethics. Right? So that's something that somebody wants to resist pragmatism of the particular sort we're talking about can say, well, accepting Rudner's argument. And so let me just end by showing 3 different views you might have about the influence of non-epistemic values here. I'll just use ethics for short. So the one on the top is maybe the most traditional or objectivist or value-free one. These terms are all pretty conflated in the literature, but you'll get the idea here that evidence is influencing rational degrees of belief, and maybe other things influence that too, or should influence that. For example, if you're a Bayesian, then prior should influence that. But no ethics yet. And rational degrees of belief might be what should influence rational acceptance and rational action, and where the ethics come in is just pretty far downstream when you're determining what you ought to do. And that's what you should do, actions other than the action of believing the hypothesis, right? Then a slightly less objectivist view would say, well, no, ethics are relevant earlier on, and if you accept Rudner's argument, maybe you think you're bound to this kind of view where ethics help influence what's rationally acceptable. But again, it looked like that argument doesn't address rational degrees of belief. And it's not clear that anything in the James or Rudner style pragmatisms did. And if you wanted to take up that issue, you'd have to make some kind of argument for ethics having this earlier influence, or that they should have this earlier influence on rational degrees of belief. But that seems like something that hasn't been shown. Okay, that's all. I can also say, I guess there's 2 other things we can discuss if people are interested. I'll just put those up on the screen, but otherwise, that was it.
Thank you very much, Matt. Elliott, do you want to take a couple minutes to answer? And then
yeah, or I should say, try to answer. Yeah, good questions and comments. So let me see if I can say something consistent here. So the Joe argument tells me that people, I mean, I buy that argument. To me, that's the point that James is making. I think people are sometimes in a position where they ought to believe things in spite of the evidence and not be evidentialists. How can I then go on to say that scientists might have a special duty to not do that? I guess I want to try to say both of those things. I mean, if Joe, in my little example, is in many lines of work, maybe there's no catastrophe or there's no especially bad consequences for him believing in God. Scientists, when they work on their research, I feel like it's a special duty they have to be evidentialists about that. Of course, maybe I can make Joe, suppose Joe is a scientist. Well, maybe Joe in the lab has, an evidentialist hat that he wears. And when he goes home at 5 o'clock, he takes that hat off, and that's the place where he can believe in God to save himself from depression. So that seems consistent and attractive as an idea to me. On James's argument, before I get to Rudner, I find the argument based on Joe just compelling as an example, and I don't feel like I need to do anything fancy in terms of invoking inference to the best explanation or anything. It's not that I think that's got to be wrong, but it just seems to me clear. I mean, it's pretty much as clear as anything ever is in philosophy that that people in that situation not only are permitted to do it, but they really should believe things upon insufficient evidence. On Rudner, I mean, I do like the line that Dick Jeffries took, which basically rejects the idea of dichotomous accept, reject. The epistemologies that I'm not a Bayesian as Dick Jeffrey was, but still I feel like the epistemology I'm comfortable with involves comparing hypotheses with each other, talking about better and worse, and if in some cases I'm happy to be a Bayesian, not a lot I'm not, but in some I may actually able to talk about high degrees of belief being warranted by the evidence and so on. But out and out, accept and reject, no. So that stops the specifics of Rudner's argument. But as Rudner himself realized, maybe there are contexts in which ethical considerations should affect degrees of belief or something else like degrees of belief. And I have this, I don't feel like I have this clear in my mind completely, but I feel like the Stein paradox material is relevant here. That, I mean, we might, before you learn about shrinkage estimators, you might think, look, there's one correct way to estimate, the frequency of high blood pressure in Beijing. Here's how to do it. And it turns out that it's more complicated than that. It's a question of whether you situate that in the context of a larger problem, or you take it as a problem unto itself. And to me, that is a pragmatic decision. I mean, that's what I was trying to get at when I talk about the two labs, Lumper and Splitter. I mean, they have different projects in mind, and that justifies them using different estimation procedures for the same quantities that they're dealing with. So that's maybe a way in which something like Rudner is entering in here, and James, but it's not about acceptance. Yeah, so I guess that's the comments that I can offer now.
Thanks, Elliott.
Is it to your satisfaction, Matt?
Oh yeah, I want to allow time for other people to say things.
Okay, we can take there are already a few questions, so let's see. Eric Seguin would like to ask a question. Eric, if you want to switch on your microphone and your video.
Hey, sorry. My question might be a little bit simplistic, but it seems that maybe there's an assumption of a consequentialist ethics going on here, where the question becomes, the person should adopt this position with respect to the evidence before them when it comes to non-epistemic considerations, or sorry, with epistemic considerations. And then when it comes to non-epistemic fallout, as it were, you're assuming a consequentialist ethic. But it seems that if you do that, then there is something to be said about the probability of the either desirable or undesirable outcome coming to pass. And so it seems that both the epistemic and non-epistemic considerations are subject to similar units of measurement, and therefore similar types of scrutiny when we evaluate which action is best to take. Does that seem accurate?
I'm going to need some, I think, help here. So back to Pascal and Pascal's wager. So we have this thing called the probability that God exists. Let me change the problem so it becomes a little, so it can illustrate what I wanted to. So suppose H is, we're talking about whether to take the COVID vaccine. And one of the things we're talking about is the possibility that we'll be around people who are themselves infected. So as we live our lives, each day there's a probability that we'll be within 6 feet of someone who's got the disease. And that's relevant in deciding whether or not you should take the vaccine. It might not be the only thing that's relevant, but this prudential thing, I don't want to get the disease, is certainly a relevant consideration. So now I can maybe get to the point I wanted to make in response to what you said, Eric. What's this probability here? Is it just, I made up something about how I feel about, what's out there in the world? I mean, it seems to me that the rational thing to do here is to try to get a good estimate of what the true value is of the probability of, in your daily life, you're being around people who have the disease or not. So I would ask epidemiologists to tell me, how much COVID is there in Montreal? Where are the people who have the disease likely to be? But I don't want to go there. And you want objective, you'd like it, if you can get it, to get objective information about the probabilities here. Which I think is fine as far as decision theory is concerned. Although often decision theorists say, look, the agent should just use his or her subjective degrees of belief, subjective certainties, or the lack thereof, and calculate based on that. And people, of course, we all do that. But I think we often are able to strive for something better, and we ought to get objective information about the risks we run by doing this or doing that to inform our decision. But what I'm uncertain about is whether this is actually addressing the question you asked, Eric.
Sorry, Elliott, I missed you at the end there. Did you?
I was asking whether what I said is addressed the question you were asking.
100%. Yeah, I think it's.
Oh,
I'm thinking it may be more of Heather Douglas and the kind of questions about, you know, in the absence of certainty, what's the right decision to make?
Right.
Obviously,
Right.
seems to be informed by that same logic
Right.
applying to the vaccine, right? It's this desire for absolute knowledge, and in the absence of it, what consequences?
Oh, you just reminded me of something else you said that I had a thought about, which is you said you talked about consequentialism, and in all the examples I talked about, that's what I was doing. I mean, that's what Pascal does. He's like, thinks of what are the consequences of believing in God, of not believing in God, when there are two possible states the world might be in. And I think it would be interesting to revisit these kinds of problems from a non-consequentialist point of view and think about how it would go. And I haven't done that, but that's an interesting project, I think.
Thank you. We have a question from Yves Gingras. Yves?
Hello. So thank you again for your presentation. My comment in form of question or suggestion is related to using only evidence for evaluating, accepting or rejecting and these kind of things, as opposed to what we call importance or taking count of utilities, where, if I understand well, would be the place where the values would come in.
Yes.
And I think this can be, I think, a big problem. And I will take a very concrete example, is that now if you say that, okay, we have to take into, I decide to take account of values in order to, for example, the value of equity or something else, to reject or not papers, it looks like very much what is going on actually in what some people call woke activism, where you have retraction of papers, which are in fact said by the authors to be right, having no mistake in it. For example, there's a recent paper in PNAS. It's a paper in political science about killings, where he evaluates the probability of H given A, whereas people read the paper as the probability of A given H, which is exactly, as you said, two different. So the first thing they did is that they sent a commentary in the paper where they added that, look, you misunderstand what we evaluate with all the data on killings is the probability of H given X, and you comment on me that as if I had said the contrary probability. But people continue to say that, oh, it plays the right on the police and the right-wing Trumpism. So 3 months later in July, they said, okay, we retract the paper. Even though they say in retracting it that all the data are okay, the analysis of the probability we did is okay. So there it means that they just went against evidence and they put all the data, all the morality first. It's okay. It's the context is bad because it's in the context of what's going on in the States. You know, it's July 2020. So it was in a bad context. And we could give other example where if you don't stick to the evidence, you just create big problems by closing your eyes. And it reminds me of Jean-Paul Sartre, who said in the 50s that though he knew that Stalin was a real killer, he said, you should not discourage Billancourt. And Billancourt is where the workers of the plant for Renault were working, because he said, we believe in communism. Stalin is a bad guy, but if we say Stalin is a bad guy, they won't believe in communism. So don't tell Stalin is a bad guy, because it's important that they believe in communism. So it's a problem taking into account values when you evaluate the evidence.
I would like to return to the distinction between action and belief. And saying things in public is an action. I mean, there are many things, forget about, controversial political issues for a moment, every one of us, perhaps more than once a day, are in situations where we refrain from saying things that we are certain are true because it would be hurtful or many reasons. I don't think that's not, to me, a conflict between evidentialism and pragmatism. It's recognizing that what you think is true and what you're prepared to say in public are really separable. And sometimes we ought to refrain from saying things we think are true. And of course, the symmetrical thing is lying is sometimes, contrary to Kant, lying is sometimes morally permissible, indeed obligatory. And there again, what you think is true and what you say are different. So maybe I'm being too easy on myself, but I feel like these examples are compatible with this distinction between belief and action.
Thank you. We have a question by Ronald Sousa, please.
Yes, hello. Wonderful talk. Although I had to come in later, I hope that we could get the recording. But I was intrigued by at least a superficial resemblance between the Stein paradox and Simpson's paradox, and I was wondering whether this is just a superficial resemblance, or whether you see a connection.
I had not thought of that until you just said that, and that's intriguing. I don't know. I mean, that's I'll think about that some. That's
because in the case of the Simpsons paradox, you could see, in the classic example of the university that overall doesn't discriminate, but each department discriminates, or the opposite. You could bring in this question of what your interest is, the practical interest is at the moment. Should you have a policy that looks at the overall, or do you think it would be that would be excessive, and your policy is just to look at in the individual departments? So, I mean, I think it might be related.
That's interesting. You can see in Simpson, the example you mentioned of Simpson's paradox and others, you can separate issues about action from just what's going on. What are the facts about what's true here? Do individual departments discriminate or not? If they don't, why are women getting into graduate school less frequently than men? And that's the story one looks at in the Berkeley example that we're both familiar with. And it doesn't. I don't see, in that sense, it doesn't seem to have a pragmatic dimension, in the sense of it's not as like, what do you really care about? Well, I want to know why. I start with it. We all agree with it. There's this question: why are women getting into graduate school less frequently than men at Berkeley? And one possibility is that individual departments are discriminating against women. Another possibility that wasn't instantly visible was that departments aren't discriminating, but women tend to apply to departments that have a higher rejection rate and men to departments that are easier to get into. And the data is that the latter is, what was going on. But these are all, there's no pragmatic decision of the sort that comes up when I talk about lumper versus splitter. So maybe it's not connected in the same way to this pragmatism issue that I was trying to describe in connection with Stein.
Yes, thank you.
I don't see any other question, but maybe if we have just a second, I'd like to ask an add-on question a little bit here to what Ronald Sousa said, because it has to do with the lumpers versus splitters type of example that you discussed, and you said we have a lab, their lumper lab and the splitter lab, but then they would make different choices, and therefore they would take different decisions on the data. But then if we generalize this example and we say we have a university that is a lumper university, and that lumps everything together, and there is a splitter university, and then there is a lumper country and a splitter country, and then there is, where does this lead us somehow? It seems that there is something to say to be said about the total, social organization of science that would have repercussions over the, complete social organization of science, unless, unless the lumpers splitter type of choice doesn't matter so much intrinsically somehow. So what I'm sort of wondering is, does this distinction typically have such a huge impact that it should make us reconsider typically how we, work about science, think about science socially, or maybe the importance is not that significant, and what really matters is more, evidence typically, or other factors maybe than that.
I think it really does matter, because you end up with different estimates from the same data, depending upon whether you're trying to minimize total risk or minimize risk in each of several problems. And it really goes contrary to the idea that what I find out in my lab, you can take and use in your lab. And if I did my homework properly, you can rely on what I did, which, that's fine as long as you're working on the same kind of problem. If I'm a lumper and you're a splitter, maybe you don't want to take my estimate. You'd like to have my data, but what you do with it might be very different from what I'll do with it. So that's a bit disturbing. I don't know of any real world example in which some fight broke out because of this lumper splitter possibility. But I do know that shrinkage estimation is used a lot in statistics, applied statistics, where these statisticians are consulting with industry and so on. So it must have happened. All
right.
Yeah, it's very weird. And there are other weird things about Stein's paradox too that I didn't mention.
Yeah, statistics are full of surprises.
Yeah, really.
One last question. Do we have time? Elliott, do you want to?
Sure.
Yes. William, and this will be the last question we take. William Harper.
And then Elliott, I would like to hear a little bit more. I was impressed with Matt's arrows going to accept versus to probability or degree of belief. And I would like to hear a little bit more about the extent to which you want to talk about the differences between how much of your case do you want to make be one that, let's not talk about acceptance, we can all do it the other way.
Well, that's to me a detail. I think it's an important point to make in connection with Rudner's argument. I like that, but it doesn't sort of clear the decks as far as saying, oh, we can all be evidentialists now. And to me, there are two things that are still on the table here. There's Pascal's wager and James, and Joe, and then separately there's Stein. So these are both threats to evidentialism, I think, in a certain way, where non-epistemic values are involved, and I think rightfully so. Yeah. So it's not like everything's cool once we get rid of acceptance and rejection. I don't think that.
Well, let's thank again Elliott for the lecture virtually, and so this somehow concludes our let me see here, our 2021 Leblanc lectures. It seems that the 3 days went by really fast. So thanks so much, Elliott, for these 3 very inspiring lectures. It's always a pleasure to hear you, to see how you tackle specific problems. It's a real pleasure to have you here. I'll thank also again Molly Cao from the Université de Montréal for the first commentary, and Matt Barker for the commentary to the third lecture. I'll thank again also, I should say, the Department of Philosophy of UQAM for their support, the Centre Interuniversitaire de Recherche sur la Science et la Technologie, the CIRST, the Canada Research Chair in Philosophy of the Life Sciences, and the Montreal Philosophy of Science Network. I'll thank in particular, I should not forget, Hélène Carlettini of the CIRST for all the help handling organizing the Zoom, Vincent Guillain et Alain Voisard aussi for their help. And thank you to all of you who have attended the lectures, have asked questions, participated in the debate. I definitely wish we could all be together here in Montreal, in COVID-free Montreal, but unfortunately that's not the case. And continue discussions around a glass of wine, but well, we know the situation. So fortunately, another time, you're all welcome at any time to drop by. The lectures have been recorded. The videos will be available on the CIRST web page, and they will also be available on the UQAM Philosophy Department web page that is indicated here on the poster. So with that, thank you all, and see you next year, maybe for the next Leblanc lectures, or earlier, we wish, if you get a chance. So thank you to everyone.
Thanks.
Thank you, Christophe and Elliott.
Goodbye. Thank you all. I've enjoyed it.
Thank you.